This next example presents a couple of challenges. Number one, we have a secant in the equation. It's not sine or cosine or tangent. There are, in theory, arc secant, arc cosecant, arc cotangent relations, but instead we're going to rely on our original three. And the second piece of this one that's a little bit complicating is the fact that it's squared rather than just a secant. But the first thing we're going to do is approach it like we did some of the others, where we're going to isolate the trig piece as our first goal. So in this case, I'm going to add 4 to both sides, so pretty easy there. So now we've got secant squared x equals 4. Now, we're going to have to get rid of that squared in a little bit, but before we do that, let's get ourselves into cosine instead of in secant. So remember that we've got the reciprocal identity that says secant squared and cosine squared are reciprocals of each other, so we can say secant squared. Instead, we'll say cosine squared x in the denominator there, 1 over cosine squared x equals 4. So I'm just making a substitution like we did when we were studying those identities. And so now, I don't want cosine squared in the bottom, I want it in the numerator. So one thing that we can do with equations, we can take the reciprocal of both sides. So basically that just means flipping each side. So we get cosine squared x over 1, or just cosine squared x on this side. And then on the other side, 4 becomes 1/4. So I've just taken the reciprocal of both sides of my equation. And now at this point, I need to get it down to cosine instead of cosine squared, so I can use my arc cosine. So that means I'm going to need to take the square root of both sides. When I take the square root of both sides, as we know in other contexts, we need to include a plus or minus in front of one of the two sides of our equation. So I'm going to throw that plus or minus in front of the 1/2. And so really what this means is we have two separate equations that we're now going to be solving. I'm going to split this up into cosine of x equals 1/2 and cosine of x equals negative 1/2. And so now I'm going to solve these two independently. I'm going to solve these two separately by taking the arc cosine of both sides. So if we take the arc cosine of both sides, hopefully at this point we know that the arc cosine of the cosine of x is going to cancel out. So I'm going to get x equals the arc cosine, I always forget that second c, of 1/2. And then on the other equation, if we take the arc cosine of both sides, we're going to get x equals the arc cosine of negative 1/2. And so now we've got to apply that arc cosine definition that we have earlier in our notes to both of these equations that we're solving. So I'm going to move up top here. So we've got x equals plus or minus the inverse cosine of 1/2 plus 2 pi n. So that's this one right here. And then we're also going to have x equals plus or minus the inverse cosine of negative 1/2 plus 2 pi n. And so we've got to find what that inverse cosine of 1/2 is. We have to find what the inverse cosine of negative 1/2 is in order to solve these two equations. So we've got x equals plus or minus. So on our unit circle, if we want to take the inverse cosine of 1/2, we've got to get an answer that's between 0 and 180, between 0 and pi. And so cosine has the x-coordinate is 1/2 at pi over 3. So I've got plus or minus pi over 3 plus 2 pi n. And then so that's one part of our infinite answer set. And then the other part of our infinite answer set is x equals plus or minus. Now I've got to find where between 0 and 180, between 0 and pi, I have negative 1/2 as my x-coordinate. And so that happens at 2 pi over 3. So I've got plus or minus 2 pi over 3 plus 2 pi n. And so these two taken together are our infinite solution set. And then once more, we don't want to forget that we're being asked to find all of the answers that are between 0 and 2 pi. So that again requires us to cycle through and plug in values of n as 0, 1, 2, so that we get all of those answers. And so again, the complicating factor here is we've got to split each of these individual answer sets up into two separate pieces. We've got pi over 3 plus 2 pi n and negative pi over 3 plus 2 pi n. For the other one here, we've got 2 pi over 3 plus 2 pi n, and we've got negative 2 pi over 3 plus 2 pi n. And so now we start to plug in 0 for n, 1 for n, 2 I think pretty clearly is going to get to be too big for us. So if we plug in 0 for n everywhere, those two that have the negative values, negative pi over 3 and negative 2 pi over 3, those are still going to be negative. So those aren't going to be a part of our answer set. But if we plug in 0 here and here, we've got pi over 3 and 2 pi over 3 as two of our answers. And then if we plug in 1 everywhere for n, clearly on these two positive locations here, 2 pi plus a positive value is going to be bigger than 2 pi, so we're not going to include those. But for the others, if we go negative pi over 3 plus 2 pi, so negative pi over 3 plus 6 pi over 3 gives us 5 pi over 3. And then down in the bottom here, if we plug in negative 2 pi over 3 plus 2 times pi times 1, so negative 2 pi over 3 plus 2 pi, so negative 2 pi over 3 plus 6 pi over 3 is 4 pi over 3. So for most of the other examples, we've only gotten two answers between 0 and 2 pi. This time we got 4 of them, and that should make sense since we've got this squared here, and when we take the square root we get that plus or minus. So that means we're going to have more possible answers than we normally would.